We found equations with one solution. We found equations with no solutions. Let's look at infinitely many solutions. Which of the following equations results in infinitely many solutions? Okay, so let's solve. If we look at this first one, we can go ahead and combine like terms on the left, right? So we're just going to rewrite this one here. And if we combine like terms on the left, we have 7x plus 5 equals what? Well, if we distribute, we have 7 times x plus 7 times 5, which is 35. So we've got 7x plus 5 equals 7x plus 35. Now, if I want to get x by itself, what do I need to do? Well, I need to start by subtracting 7x from both sides. This is just one option. You can do it a couple of different ways. If I subtract 7x from both sides, I'm going to have what? Well, I'm going to have 0 plus 5 on the left, and I'm going to have 0 plus 35 on the right. Does 5 equal 35? No, absolutely not. 5 doesn't equal 35, so we have no solution here. So we won't choose A because we're looking for infinitely many solutions, which means we can plug in any number for x, and it's going to hold true on both sides of our equation. So let's go ahead on to choice B. 3x plus 35 equals, if we distribute that 7, we know we have 7x plus 35. And we can go ahead and combine like terms here by subtracting 7 from both sides, 7x rather. And when we do that, we're going to have, on the right-hand side, our 7x's are going to go away, right? And on the left-hand side, we're going to have negative 4x plus 35 equals 35. Okay, what now? We need to subtract 35 from both sides. So we have negative 4x plus 35 minus 35 equals 35 minus 35, which is 0, right? 35 minus 35. And so we have negative 4x equals 0. So what's x? Well, any number divided, 0 divided by any number is going to give us 0. So x is 0. So we have one solution. 0 is a solution. If we plug it in for x, we're going to get the same thing on both sides of our original equation, or any piece of our equation. So let's go ahead to choice C. Maybe it has infinitely many solutions. We know that if we combine like terms on the left-hand side, we have 7x plus 35, right? We did that in a previous equation. And on the right-hand side, we also have 7x plus 35. What's this telling us? We've got exactly the same thing on either side of the equation. So anything we plug in for x is going to work on both sides of the equation. I think this is the one with infinitely many solutions. Let's keep going and see if you guys agree. If we subtract 7x from both sides, we have 7x minus 7x plus 35 equals 7x minus 7x plus 35. So on the right-hand side, we have 35. What do we have on the left-hand side? 35. That means that we've got infinitely many solutions. Same number on the right as on the left. Anything we plug in for x, whether it be 1 or 100 or 1,000 or 1 million or 2 million, we're going to get the same thing on both sides of the equation, which tells us there are infinitely many solutions to our equation. What about D? Why isn't D the correct answer? We know C is, right? But why not D? Well, on the left-hand side, we know from previous equations that 7x plus 35 is what we get when we combine like terms. And on the right-hand side, we have 3x plus 15 when we distribute that 3 all the way through. So if we solve this by subtracting 3x from both sides, on the left-hand side, we've got 7x minus 3x plus 35. On the right-hand side, we've got 3x minus 3x plus 15, which is going to give us 4x plus 35 equals 15. I'm looking like I'm going to have one solution here. What do you guys think? Sure, when we subtract 35 from both sides, we're going to have 15 minus 35 on the right-hand side. Okay? 15 minus 35 on the right-hand side is going to give us negative 20. And on the left-hand side, we have 4x. When we divide both sides by 4, we have x equals negative 5, which is just one solution. It can only be x if we want to have the same value on each side of the equation. So we know that the answer to this equation is not infinitely many solutions. So we've done a great job in picking C, and now we've approached a bunch of different types of solution, and we can add infinitely many to our list.